The people with heart problems and brain problems are kindly not advised to watch this video because this video is gonna be with the formulas which will affect their heart and brain very badly. Please kindly note the advice and do as instructed. Hey, welcome back to Sciencing Around. Abhishek here. Yeah, you can read my name. Now let's start with the chemical kinetics. Yes, chemical kinetics. We're again doing with the chemistry part, and this is gonna be with full of formulas. Let's read. What is rate of reaction? It is defined as decrease in concentration of the reaction per unit time, or increase in concentration of products per unit time. As you can read, it's very correct. As product increases and reactant decreases, thus it's nothing but rate of reaction. So you can see the formula where rate is decrease in concentration upon time, decrease in concentration of reactants upon time taken, or increase in concentration of products per time taken. Let's take an example for your fucking better understanding. Let's see, we have an example, and any arbitrary element x becomes y plus z. Then since x is disappearing, so we give the negative sign, that is minus of change in concentration of change in time of x equals to plus of change in concentration of y upon change in time of is equals to change in concentration of z upon change in time. So simple, right? Now what are its units? As you can see, moles per liter per second. Since concentration have a moles per liter, so units are moles per liter per second, which is moles per liter second. So obvious, right? In a gas, atmosphere per meter or second. In gases concentration, we know that moles upon volume, so we can see P upon RT, PV upon nRT by the formula, where P is the moles of gas upon total number of moles into total pressure. I hope that's what's the formula. For any instantaneous rate, we can say R equals to change in concentration upon change in time. So fucking obvious, right? Now let us talk about the rate of reaction. Decrease with decrease in concentration. Yes, the rate of reaction decreases as we decrease the concentration. The rate of reaction increases as we increase the temperature. Okay, you have to learn these things. Catalyst, we can see a catalyst increases the speed of reaction. That's so important. Some reaction takes place only in light. They are called as photochemical reactions. That's so obvious, right? Photochemical, photo nothing but light. And one more important part, catalyst just increases the rate of reaction, nothing but speed of reaction. Yes, and the first two things. Most simple part of this chapter, molecularity. In any reaction where a number of moles of A, that is small a number of moles of capital A plus small b number of moles of capital B, gives us any idiotic thing. This is an idiot, right? Then molecularity is nothing but A plus B, as you can read here. Simply number of moles, summation of number of moles. Now what is rate? Rate is directly proportional to concentration of A to the power m plus concentration of B to the power n, where m and n are experimental quantities not yet defined. We cannot just calculate these things. And K is nothing but the rate constant. And also we know about the order. Order equals to m when B is in large axis, and order equals to n when A is in large axis, since A power m and B power n. So when B is in large axis, then m is the order, and if A is in we can say A is in large, then n is the order, since order is an experimental quantity too. This type of reaction is called as, we can say, pseudo-molecular reaction. What about pseudo? Pseudo is nothing but, we can say, magic. Yeah, we can say magic, pseudo forces and all that stuff. The number of molecules of the reactants whose concentration alters during reaction is called order. Okay, the number of molecules whose concentration alters is called as order. Means order is nothing but number of molecules of the reactants whose concentration alters during reaction. Okay, we can understand. It's then to an experimental quantity. So we can say concentration upon time, that is, the concentration upon time equals to K times concentration to the power n. Then we can say K equals to concentration to the power 1 upon minus n upon seconds, where we can say n is the order. Now what about rate law? In any reaction where A moles of A plus B moles of B gives us D moles of D plus E moles of E, fuck about C. So what is rate? Rate is minus times 1 upon m that it was, sorry, 1 upon n is the number of moles, minus of 1 upon a dA upon dt equals to minus of 1 upon b dB upon dt equals to minus of 1 upon d dd upon dt equals to minus of 1 upon e dE upon dt. It is the rate, and k which is equals to k times number of moles of a to the power m into number of concentration of a to the power m and concentration of b to the power n, where we know k is nothing but rate constant. Yes, it's rate constant. So fucking good, right? M and n are partial order and overall order. Yeah, m and n are the partial orders, and thus the overall order is the summation of these two, that is m plus n, and that's it. Now let us see the reaction of various orders. Now let us take the first order reaction. For example, if any reaction where any element A goes to idiot, then concentration of A naught is initial concentration of A equals to concentration remained unreacted at time t, means after some time t this much concentrated is still not reacted. Then by our formula, k equals to 1 upon t, k is rate law, rate constant, 1 upon t ln of concentration of A remain unreacted divided by concentration of A naught, which is initial concentration. Rate law, I hope these formulas are so headache, right? So general formula, concentration of A equals to concentration of A naught into e power minus kt. Simple to that, charging and discharging of capacitors, right? So dx upon dt equals to k times concentration of A naught. That's so obvious, right? And half-life, yeah, what is half-life? The time required to decay half of the initial amount of the reaction, that is concentration of A equals to A naught minus A naught by 2 and concentration of A equals to A naught upon 2. Now what is half-life, right? To explain half-life, let me give you a simple example. Now suppose I have 100 grams of uranium. I have 100 grams of uranium. After first half-life, I get 50 grams of uranium. That means 50 grams gets decayed. After, we can say, second half-life, we get 25 grams decay. After the third half-life, we get 12.5. Simply after fourth half-life, we get 6.25, and so on. That's nothing but the half-life. Now we know half-life equals to 0.693 upon k, where k is the rate constant. A very important formula, right? The half-life is 0.693. 0.693 is nothing but, we can say, ln of 2. ln of 2 upon k, sorry. So 0.693 upon k equals to ln 2 upon k, since 0.693 is the value of ln of 2. Now let's read about zero order reaction. Concentration of A, concentration of A equals to concentration of A naught minus KT. Zero order reaction. Rate of reaction is constant here. Concentration decreases linearly with time. Yes, it does. And half-life equals to concentration of A naught. Concentration of A naught is initial concentration, so half-life is initial concentration upon 2 times the rate constant. It depends on concentration, yeah, it does. And now second order reaction. 1 upon concentration of A equals to 1 upon A naught plus K times T. Plot of 1 upon concentration of A of graph is straight line. Yeah, this is some graphical sort of determination of the order. Now if the graph of 1 upon concentration of A with time is straight line with intercept time equals to 1 upon concentration of A naught, then we can say it's a second order reaction, and half-life is 1 upon K times A naught, that is 1 upon rate constant into concentration of A naught, which is initial concentration. Now let's straight away jump on any nth order reaction, and let it be any order, that is 1th or first order, second order, third order, fourth order, and any 10th order. For any nth order reaction, this is the equation: K times T equals to 1 upon n minus 1 into 1 upon concentration of A power n minus 1 minus 1 upon concentration of A naught to the power n minus 1. And for half-life, the equation of half-life is 1 upon rate constant into nth order minus 1 into 2 power n minus 1 upon concentration of A naught power n minus 1. Now fuck you know what? Fuck these formulas. I have some better thing that I'll discuss afterwards. It's okay for now. We have completed with our first part. Next time I would explain you about this thing. activation energy. So right now, thanks for watching. I know nobody's watching. I know. Until a year, nobody would even notice I was there on YouTube. So that's okay. Goodbye for now. Happy sciencing. Goodbye.